Okay, and share screen. Okay, where is it? Hold on, I need to get to that over here. No, not this one. It should be this one. Okay. No, oh yeah, this one. Okay, so what we will go over, and there are a lot of material in Java secure coding rules. So we will not be able to cover all of them. The other question is some of the material in Java we haven't learned yet. So that's maybe on some later classes material. So anyway, there are a lot of rules and we cannot cover all of them, but you will get some idea about the secure coding. Okay, it's from SEI CERT, Oracle coding standard for Java. Okay, and this the first one, the rule 00. Because we haven't learned regarding Java and internet programming. So, but later when you take some other class, and like especially with web development, full stack web development, if you use like a Java string framework, then at that point that should be covered in that kind of class. Okay, and the 0-1 declaration initialization, there are, I remember it's not a lot of material and it's pretty straightforward, so we can skip that. And in summer break, if you are interested, you can read on your own. Okay, and all of this are quite useful in the future if you, especially when you look for internship or like a job. And if you also know all of this, because by my knowledge, some of this also appeared as some interview questions. So if you can fully understand all of this and put them on your resume, that will help a lot. And the expression also, there are not a lot of material. Okay, and I think it's pretty straightforward. You can read the numeric and operation, character string, and all these 5 I strongly recommend in summer if you have time. And by this class knowledge, you should be able to understand all of them. And we will start with 05. I will not cover all of them, just to quickly go over with some major information. Okay, 5 and 6 method, and we will see if we have time. Okay, exceptional behavior and the visibility and automaticity. That's mostly also involved with like the thread programming. So that's a very advanced Java programming stuff. And I'm not sure if we have any course cover regarding parallel program, but that's a very important part. Okay, I will see if in the future CS2 I can at least cover some. Okay, but this semester we don't have time. And input output. Okay, and serial. And so, and miscellaneous we are going to cover a little bit. Okay, and Android, because some part we already, based on our knowledge, we should be able to understand, but some of we cannot understand. And Android is for the mobile phone, and that's quite helpful. But we have a class, okay, about Android development. So if you're interested, you can consider take that class. So we will start with rule 05. Okay. Rule 05 is about object orientation. You will see there are quite a number of rules. Okay. And the first is limit the accessibility of fields. And this is pretty straightforward, is that we know that, because for object-oriented programming, is it this? And all of us know this, it's violate encapsulation, is it? So that's why over here it said non-compliant code example, is that you shouldn't have public. The OOP concept is encapsulation, so this is not a good design. And then the good design is you need to give your instance variable as it, like in this case called total, as private. Okay, so we all know that. What the next one shows is public mutable fields. Okay, so over here, what it's show is also private mutable fields. Okay, so in this case, this HM, as it's because it's a hash map. Hash map is also from the collection framework. In CS3, you should be able to learn that concept. Okay, and basically in one of our lab, we kind of have the hash idea, is it? So that's, and over here it's also private, is it? But over here we also declare it as static final, is it? And static final, that means you shouldn't change it, is it? And the static means it's a class variable, is it? And the final means you shouldn't change it, is it? And generally speaking, with static final, that can represent as constant, is it? And but like over here, it shows some instance variable. Is it? If like in this case, it's an array. Is it? It's an array, but you make it as a public. Is it? And even though you declare as static final, is it? But that's not good. So what over here it shows, generally speaking, compliant is you have it as private, okay, private. And it also recommend you can return some individual things, okay. Later on, we will also see even this get item, we need to be careful, okay. And then next, it also shows, yeah, this is also quite important. And this item is it is an array, is it? And it is an array if you have a instance method, suppose you call it get items, is you wanted to know of the contents of this array, is it? If you don't do clone, if you just do items, then basically you violate the private, is it? Because this item is private. So in main, generally speaking, is it in main? In main, if you have an instance of this class, is it an instance of this class? Is it then, suppose we call it an instance, suppose we call it, is it? Then if you call that get items, is it? If we don't have clone, then what is exposed is the item, is it? So basically you expose the item, but then that's violate private, is it? You don't want it to be exposed, it's encapsulated, so it's violate, is it? So generally speaking, in this kind of case, we need to be careful, okay? Then what you can do is you can have you can call clone, is it? If you call clone, then it's a copy of the array, is it? Because is it in heap, is it? So here, suppose it's the original copy. So if you call clone, then you have copy, is it? The copy of, so then that's fine, is it? So the original, no touching, is it? Is it? So then that's fine. So that's the concept here, okay. But here you see, if you want to get a single item, so one of the item within this items, is it? Then that's fine over here. But also later on, we will also see, this is fine. That's because the type of this array is string. This string is what? Is immutable. Is immutable. So then that's fine. You return this item, okay. You return that item. And the other, if it's not a string, suppose if it's employee, then if you suppose here is employee, and then if you do this, that's not allowable, okay? Then that will cause trouble because you exposed Okay, then comply. So we already know, yeah. So you can do the clone one, okay, or you can do over here. It says what you can do is you can also declare something called item list is from the list framework. Then you call what you call that collections. We already learned that collections, and within it, it has a method called unmodifiable list. Okay, then you can create something like this. Okay, then that will be doable. So that's the first case. Then the second rule is a preserve dependence. Okay, so this is regarding subclass, superclass. So let's take a look what's going on here. Okay, so here if we take a look, we have a class. Okay, this is package level of class. It's not defined as public, so it's package level. The instant variable, this no violation, it's private, is it? And over here, what it did is a withdraw function. It withdraw a certain amount. So far looks good. And then let's see this bank account. The bank account is a subclass of account, is it, because it extends, okay? And over here, you override the superclass withdraw method, is it override? And within this method, what you did is you first do some security check, suppose, because bank account is supposed to be very secure, is it? And over here, you define some method, is it, called security check, okay, security check. And then you here says suppose you do some check that a commander may proceed, is it? So if you pass the check, then you can withdraw some money, is it? So that's what this function does, okay? So then over here, then in main, you can create a bank account and then do some withdraw, is it? And over here it says at a later time, the maintainer of account class add a new method called overdraft. Okay, overdraft, let's see. The overdraft, then what it does, so you update your class, superclass in this case, and then you add a new method called overdraft. Okay, overdraft. This overdraft just to do something, is it? And then over here, okay, you still do the bank account subclass, is it? Then over here, you call withdraw. And the withdraw will enforce the security check, is it? And okay, you pass the security check, then you do the overdraft, is it? You do overdraft. And it says, even though it works, is it? But it says it can add some dangerous attack vector. Okay, attack vector. So here, let's take a look. So here is some attacking app, suppose. Okay, what it did is it just do the bank account, create something. Then it's just do the overdraft. So it bypass that security check, is it? In this case, it's bypass that. So that's not good, is it? So over here, what's recommended we do is a compliant solution is for the overdraft, as if for the overdraft. Then what it says, you do the override overdraft, is it? And then you can throw some illegal access exception. Okay, so here it provides you, so whenever you write multiple classes, you also need to be careful, okay, how to protect it. And what next shows about the calendar class. So Java language itself has the calendar class, okay. So over here, we create a subclass that extends the calendar class. And here we have a method called after, okay. That after method will after something. That here is the parameters object when it's override, okay, from the calendar. So what it checks is, it said, okay, if this parameter, is it, if it's some instance of this class, is it? And then also you can compare do the compare, then you return true. Otherwise, you do what? You can call super, is it? And here we also have, here it also have override the compare to, okay, compare to method. And over here, it also have another method called compare days, okay? So then in this main, it create an object of that calendar subclass, is it called set time, and some set function, is it something, okay, then call the after, okay, after. And let's see what's the problem over here. So over there, the calendar, is it the calendar extends, is it? It just extends from the calendar, this subclass, okay. And what over here, the compliant solution, what it did is, so over here, it define a final, okay, it defines some a class called forwarding calendar, okay. So this forwarding calendar has an instance variable C, is it? And the type over here, it has a keyword final, okay. So be very careful. And if it's defined as final, that means you can only initialize it once. Only initial once. Okay, so that's what's that final, okay, quite useful. And in this case, then this is a constructor. Is it okay? Constructor, you initialize this say as something, is it? Or you can just do, here's the return and after compare to, is it? And then let's see, okay, so here we have a subclass. Is it this subclass extend from the forwarding calendar? Is it okay? The forwarding calendar we just defined. Is it okay? Forwarding defined the calendar, and what it did, it's constructor. Is it the constructor? Then it the parameter is the calendar implementation. Is the calendar implementation. And the calendar implementation, let's see, calendar implementation, calendar implementation, where is the calendar implementation? That's a calendar subclass we defined. Calendar implementation. So anyway, here I didn't see where's the calendar implementation. I didn't see it. So anyway, it's some class. Is it? It's called calendar implementation. And then over here we write that after function. Is it? And over here we check if it is a calendar instance, and then and you also call the compare method to compare, is it? And over here, you call the, we override the compare to method, okay? And here is that compare, compare days method. And then over here in this calendar, okay, so over here we create an instance called, calendar implementation, is it? And then calendar implementation, you can set time, is it? Set time. And then you can also call set, is it? You can call set. And then over here, we have the calendar implementation too. We have the second. So over here, so this is C, is it? C is a composite calendar, is it? Composite calendar. The composite calendar, okay, yeah, this is our composite calendar, is it? The composite calendar, it's extend from its superclass, is it? The superclass's instance variable, that C, is calendar implementation, is that class, but it's a final one. Okay, it's a final one. Final one means you can only initialize it once, is it? So whenever we create an object, and it will call its instructor, is a constructor. If it's called its constructor, then it's being initialized, okay? If it's initial, you won't be able to change it. Okay, you won't be able to change. So then that's going to be safe in this case. Okay, so that's what this part means. And then next, let's see. The third one is prevent heap pollution. Okay, heap pollution is said it's when a variable of a parameterized type reference object is not of that parameterized type. Okay, so what does that mean? So generally speaking, it involves so because you remember when we discussed collection framework, is it? Generic framework, yeah. And before that, we discussed generics, is it? When we discuss generics, we also mentioned raw type. Is it? You remember generic type, raw type, and we also have discussed the wild card. Is it of those concepts? So basically, list is it? List defined in the collection framework for the later version. Is it? So of the versions that we learned so far, they are generic list. Okay, but legacy code. So before the generic was defined in Java. Okay, then you can do something just like this. You don't specify the type. That means you just wanted to make it very broad coverage, is it? Then in this case, okay, that's also allowed legacy code, is it? But over here, we will see that will cause some problem, okay? So in this case, so you have this class called list utility, okay? And we have this method called add to list. Add to list is a parameter type, it's legacy. It didn't specify this list is a generic one or some specific type, is it? Okay, and then, okay, you can do something. So that's fine. But over here it says if you try to run the code, it may give you some warning, okay, unchecked warning. And then in May, what you did is, oh, I create a string type of array list. Is it? So this is type is string type. And then when you do add to list, when you call this method, whatever you plug in is not a string, it's an integer, is it? And it won't complain, okay, when you run. But when you run, it's when you get to this specific statement, then it will throw some exception. Okay, but sometimes that may be not a good option in this case, because what really happens is this. What really happens is this specific. The problem comes from here, is it? But the exception got through until the system.out print line, is it? So that's not a good option, okay? So this kind of situation, we call it a heap pollution, okay? And how do we solve the problem, is it? So here it proposes some solution. One solution is you write something like this, okay? So you specify it's a string type, is it? And then whatever you pass in should be also string type, okay? And or what over here shows another solution is you keep the legacy code, is it? Keep legacy code. And then over here it says, so this list is a string array list, is it? But then we create a checked list. We create it from the collections called checked list. Okay, create this one. And then you pass in, and then in that case, then it will take 42, okay, because over here you specify the type, okay. Then in this case, that will pass. That won't cause a problem. So it's it will work with legacy code. So here it says legacy code, because you know when you work in a company, is it? A company, assuming like Microsoft, is it? Microsoft Windows is just you keep updating, is it? A new version, is it? But Microsoft won't just completely wipe out of its old Windows software. It's just updating, etc. So a lot of time in the system you have legacy code, just like this case, is it? But later on the language itself, assuming like Android, etc. And then later on the programming language itself has a lot of updating. Then in this case, how do we make them compatible with each other? So we need to find some way to deal with that. And over here, it also shows here it says this is also non-compliant. Okay, so that method looks like nothing new here, is it? And then over here, this method print number, is it? This method looks like a generic method. Is it generic? And then it says, okay, I want to define the type. If the type is integer or double, is it? If it is not, then I'm going to make it a generic type. Or if it is, okay, then you can make a generic type. And then, okay, in our main, we have double, we have integer, is it? And you can see, okay, over here, that adder, you add a double, is it? And over here, you add an integer, is it? And when you run, is it? When you run, you will see the result a little bit off, is it? Because over here, you add a double, is it? But the result not showing double, is it? It's still showing as integer, is it? So how do we deal with that? It's that we can do, we learned this, is it? Parameterized collection, is it? So basically, you can define the method itself, is it, as a generic method. So this is a generic method, is it? And if it is a generic method, then you won't have that trouble, is it? Then in this case, is it, you add the D, is it double, then it will give you print out still double, is it? So in this case, because over here you define that generic method, this method is a generic method, so that will take care of, okay? And what the next one shows, here it's a non-compliant example for variadic arguments. It's so that means you have multiple arguments, okay, multiple arguments. So in this case, it shows we have this function called modify, is it? So it has so this parameter it's we call it variadic arguments, is it? So then it didn't specify how many, is it? So because it's variable, it's changing as a number of parameter, not a specific like we provide one parameter or two parameter or three parameters. In this case, it's changing, okay? So that's why over here we have two lists, is it? Then you call the modify method, is it? And you pass in and you try do something, is it? To try do something. Then over here it says if we run the program, it will cause error, okay? So that's not a good option, okay? So what it recommend is you, instead of that, you use array of lists of strings, okay? Not to do something like this, okay? That's not a good option. Instead, you use an array, okay? Then in this case, you can deal with it. Is it over here? Then you have two lists, is it? And then you put this two lists in another list, is it? And then you call it modify. So that's an option. Or the other option is you have a list of lists, okay? So in this case, you have a list, is it? And within the list, you have another list, is it? So this is kind of like a two-dimensional array, okay? Not a single. Then in this case, that also works. So that's just a recommendation. And the next one, what it went go over is provide mutable class with copy functionality, okay, to safely allow passing instance to untrusted code. So let's take a look over here. So here we have a class, Okay, so this class is a final class. Okay, and like we said, once something defined as final, it can only be initialized once, is it? And regarding class case, if the class is final, then cannot be used as superclass. So no other class can inherit. Okay, so in the hierarchy, then this is we can see it's kind of like a leaf node, is it? But it's not a tree structure. So it's that's why, because based on the name, it's a final class. So you shouldn't create some other class as that's a subclass of this class. So anyway, so for this one, the issue is that so we have this class as mutable, is it? And you have this private date, is it? But did you see over here, you have that get function. That get function, then you return the gate, is it? Because your initial purpose, is it? So on heap, is it? On heap, you have this date. This is the heap memory, is it on here? And so that's the object. It's protected, is it? Protected. But if you have the get, is it? Then it's exposed. Then anyone can get access to it. That's not allowed. Okay. So we shouldn't do that, is it? Then what should we do? Because a lot of times you really want to do something with the contents of it, is it? Then in this case, okay, what you can do is you also not just a class as a final class, is it? And the instance variable, you also make it as a final. Then in this case, this state shouldn't be allowed after it's once after it's initialized, shouldn't be allowed to be modified. Is it? Okay, then this is mutable class. Is it? Okay, you create the date. Is it? And this is through, and if you take a very close look, you will find you initialize this state, you call new, is it? You not directly assign it to the get time, is it? You didn't do that. You call new, is it? New, because that's MC, is it? So on heap, so this is MC, is it? So when you call new, is that you're going to use it to create some other date object. Is it? So the date is going to be here. Is it? As new, is it has its own stuff. Okay, then in this case, this mutable class, is it? And this mutable class, and it's a constructor, is it? And it's create the date, is it? Also with what? With the new, is it? So it's create a copy from whatever information, is it? So we call this kind of case, defensive copy. Okay. Oh, I forgot to mention there is another concept here. And we learned the constructor, is it? Constructor we learned. And I remember we learned, we said there are two types. One is without parameter, one is with parameter. Is it? But there is a third case, has a special name called copy constructor. Okay, so be careful. The name is called copy constructor. Okay, so what does that mean? Copy constructor is so this is constructor, so the same name as your class name. But the parameter type, if you take a look, it's also the same. Okay, so the parameter type is also the same as the class itself. Okay, and this kind of constructor, we call it a copy constructor. Okay, why we see the concept or call it copy constructor? Okay, because the idea is you already have an object, is it? So this is an object of a class. Is it? And you want to use it to create a copy. Is it? A copy from the object of this specific class. Is it? You want to use it to create a copy. Is it? That's why we said this is called a copy constructor. Okay, copy constructor. Okay, so that's the idea. Just remember, okay, this is a concept. It's also quite useful. Copy constructor. Okay. And then let's see over here. This is a compliance code. Is it for the copy constructor? Basically, it does deeper copy. It does deeper copy. And over here it says you can also do. We said call it a public static factory method. Is it? So over here, this method is just a constructor. Is it a constructor? And what over here it try to show us is like the get date. Is it? What the get date returns? Do you see? It's not going to return date itself. It's going to return its copy. Okay, so be careful because over this date, it's a private. Is it? And the final one. Okay, you don't want it to be ever exposed and changed. Is it? After an instance created. Okay, so that's your goal. So that's why whenever sometimes you do want to know the information. Is it? Then you just return a copy of it. Okay. And over here, we also define a static method. Is it? This static method is as get instance. Is it get instance? And what it returns, if you take a look, so that's why over here we call it a static factory method. Is it? So its return type is a class itself. Is it? And you try to return something from the parameter. The parameter type is also the class type. Is it? So these three things matches with each other. Is it? But did you see when it return, it's not just return MC. Is it? What it's return? It's from MC get date, but it's return what? Return a copy of it. Is it? So this is also a deeper copy. Okay, so be careful. And over here, it shows a compliance solution use clone. Okay, using clone. So let's see how did we do this. And what we do over here, we implement the clonable interface. Is it? The clonable interface, the clone method, then you need to override it. Is it? And over here, what I did, not just call super dot clone, is it? And for the clone date, is it? What you need to do is you need to call the clone, is it? So this is a deep copy one. Okay, deep copy one. So just be careful about this. And over here it says we can also do some compliant solution with clone, but using final members. So let's see, how do we do this? Is it? And over here, it's we have that date as private and final. Is it? And over here, we do the get, we return the clone. And what over here we did, this clone method, is it clone method? So it create a copy of the date. Okay, the date clone. And then what it did is it has a temporary variable, is a cloned, and the type is your class type, is it? And but over here you did. Over here, what you did is you call this constructor, is it? Create a new object, is it? And then you return it. Okay, you return it. So we can also do something like this, okay? And it shows another compliant solution is as an unmodifiable date wrapper, is it? So over here is you just provide some wrapper. Here is as an unmodifiable date view, is it? And the view normally you can only see it, you cannot change it, is it? Okay, so what it did is, okay, it does the constructor, is it? And then you can set a time, is it? And then over here, we have this mutable class, is it? And the mutable class, if you take a look, you want to have the get date, is it? what is the get date to return? It's going to return that modifiable view. Is it? Modify that view you return, or you create an instance of it. Is it? But what that instance has? That instance is going to have some information. Is it? Some information from the date. Is it? So yeah, in this way, you can also get around with the shallow copy issue. Okay, so next one, the 5 says do not return reference to private mutable class method. Be very careful, okay? So over here, we already know this because D is mutable, okay? And then be careful, if you don't define D as date, if you define it as string, then this is okay, okay? So it's legal then. Legal, is it? Because why? Because string is immutable. Is it immutable? So even though attacker wanted to do some evil things, attacker cannot. Okay, so that's why. But the date is different. Date is different. Date is mutable. Okay, so that's why we don't do that. And we already explained that one solution is you can do the clone. But later on, we will also see clone is also not a good option, okay, in Java regarding security, okay. And then let's see over here, we have this class. This class has the instance variable is an array of date, okay, array of date, and you initialize it, is it? And then you have the get method, is it? And then to return that array. Definitely, we know that this is wrong, is it? And then what you really should do, this is a really deep copy, okay, really deep copy. And what we can do over here, is this get date it does return an array of the date, okay, but because we want to do deep copy, okay, not the array itself, is it? So over here in heap, is it? So this is original, is it? Originals the date, is it? It's called date, yeah, date, is it? What you're going to do is you're going to have an exact copy, is it? So every day, like 2020, is it? Then over here is going to have 2020, is it? A copy. You need to create this deep copy, and even within this array, each element needed to be its own copy, is it? So that's why you needed to have new for the array, and then within the array, is it? Each element you also call clone, is it? So that's over here, you get to the clone. Is it? Get to the clone. So then you can return the dates array, okay? So that's a real deep copy one. And then let's see, yeah, similar. So this hash map, is it? So it's just like our linked list, queue, those kind of ADT, okay, for the from the collection framework, okay? And so this is some data structures, and then over here, okay, you do something, is it? And here you get value, is it? And here you get value, you see. So outside in main, is it? Outside in main, you have this hash table, is it? A hash table. And then you can retrieve this value, is it? Then you can do something, is it? Because anyway, this hash table, you can still use it, is it? So this is unsafe, is it? So that's not a good option in this case, okay? Because it's mutable. Okay, then what should we do? Is it a compliant solution? What you do is, and also be careful. You remember when we learned collection framework, we also say, you remember the array list itself provided a clone, it's a shallow copy, okay? Be very careful, it's a shallow copy. So that still will not work very well, okay? So let's see if we have some good solution. This is a shallow copy of that hash table specific thing. Okay. So over here we create, we call this class. This we create an instance of it, and then we call that get values. Is it get values? And get values, and then you can still do remove. Is it? You can still remove. And here says untrusted caller can only modify the copy. And over here it's okay. Okay, over here, because in this case, this hash table, both of this, both integer and string, is it? Both of those are immutable. This is immutable. So even though this data clone itself is a shallow copy, but because of this is immutable, so this is fine. But if you change this to like the date and change this to employee, suppose, then this is not safe. Okay, so it depends on the type. The type, okay, in this specific case, it works. Okay, so so that's the general information about the